Hello guys, today we will continue from where we stop on binomial distribution. So today we'll be solving some practical examples, and let's start with what? Example 1. Example 1. Now medical observation shows that the probability of surviving a neurosurgery is 0.72. Medical observation shows that the probability of surviving a neurosurgery is 0.72. Out of 6 patients that registered, for the surgery, the question is find the probability that only 2 will survive. Less than 4 will survive. 5 will survive. And IV, what is the expected value of what is the expected number of patients that will survive the surgery. The question says, a medical observation shows that the probability of surviving a neurosurgery is 0.72. What did I say? Medical observation shows that the probability of surviving a neurosurgery is 0.72. Now, out of 6 patients that registered for the surgery, find the probability that only 2 will survive, less than 4 will survive, only 5 will survive, and what is the expected number of patients that will survive the surgery. So let's start. Looking at these questions, we know that it follows for a binomial distribution because number 1, it has 2 possible outcomes, which is what? Success and what? Failure. The patient can either survive or not. Now, and again, what makes it a binomial? Because it has 2 possible outcomes, and it has a finite repeated Bernoulli trial. So that's what makes it what? A binomial distribution. That's what makes it to follow a binomial distribution. So let's start with number I, which says the probability that only 2 will survive the surgery. The probability that only 2 will survive, which is I, probability of s equals to what? 2, which is the probability of only 2, that only 2 will survive, is equal to what? Is equals to n. Our n here, let's define our n. You know that a binomial distribution, in binomial distribution, the probability of s equal to small s is equal to n combination x q raised to power x q raised to power n minus x. So here our n, in the equation, our n is equal to what? 6. Our p is equal to 0.72, and our q is equal to 1 minus 0.72, which gives us 0.28. 0.28. Is there no other thing that we need? No. So the probability of x equals to 2, which is the probability that only 2 will survive the surgery, is equals to equal to what? 6 combination 2, 0.72 raised to power 2 multiplied by 0.28 raised to power 6 minus 2. Our 6 combination 2, so 6 combination 2 is equals to what? 15. 6 combination 2 is equals to 15 multiplied by 0.72 squared. 0.72 squared is equals to 0.5184 multiplied by 0.5184 multiplied by 0.28 raised to power 4 will give you 0.00, which is equal to 0.006147. So multiplying this, we have this times so the probability that only 2 will survive, the probability that only 2 will survive is equal to what? 0.0478. 0.478. This is the answer, the probability that what? Only 2 will survive. Okay? The probability that only 2 will survive is 0.0478. Let's look at number I, which says less than 4 will survive. Less than 4 will survive. The probability of x less than 4 is the same thing as well. Probability of x greater than or equal to what? Less than or equal to 0. Probability of x less than 4 is equal to probability of x less than or equal to 3, which is equal to probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3. So probability of x equal to 0 we have is equal to probability of x equal to 0 is equal to 6, because our n is equal to 6, combination 0 multiplied by what? 0.72 raised to power 0 multiplied by p multiplied by 0.28 raised to power 6 minus 0, which will give us which will give us 6 combination 0 is equal to 1. This 0.73 raised to power 0 is equal to 1, and 0.28 raised to power 6 will give us 0.000482. So this is the probability of x equals to 0. So let's get the probability of x equals to 1. Probability of x equals to 1 is equals to 6 combination 1, 0.72 raised to power 1, 0.28 raised to power 6 minus 1, which is equals to 6 multiplied by 0.72 multiplied by 0.00172, which is equals to 0.00743. So this is the probability of x equals to 1. Now the probability of x equal to 2 is equals to 6 combination 2, 0.72 raised to power 2, 0.28 raised to power 6 minus 2. So we have written this one to be 0.00478. So let's solve for the probability of x equal to 3. The probability of x equals to 3 is equals to 6 combination 3, 0.72 raised to power 3, multiplied by 0.28 raised to power 6 minus 3. So we have this will give us 0.00048 no, this will give us this is equals to 20 times 0.373 times 0.0219, which is equals to 0.1636. So the probability of x, the probability that less than 4 will survive, which is equals to probability of x less than or equal to 3 is equals to 0.000482 plus 0.00743 plus 0.0478 plus 0.01636, which is equals to 0.2192. So the probability that less than 3 will survive the surgery is equals to 0.2198. Okay. Now the probability that only 5 will survive the surgery is equals to probability of x equals to 5 is equals to 6 combination 5 multiplied by 0.72 raised to power 5 multiplied by 0.28 raised to power 6 minus 5, which will give us 6 multiplied by 0.1934 multiplied by 0.28. This is equals to what? 0.3249. 0.3249. That is the probability that only 5 will survive the surgery. Okay? Now the final question says, what is the expected number of patients that will survive the surgery? What is the expected number of patients that will survive the surgery? You know, for a binomial distribution, the expectation of a random variable of a binomial distribution is equal to what? NP. So our N in this question is 6, which is the number of patients that register for the surgery, and our P, which is the probability of surviving the surgery, which is 0.72. So the expected number of patients that will survive is equals to IV. The expected number of patients that will survive is equals to NP, which is equal to 6 times 0.72, which is equals to 4.32. Thank you and God bless you. See you in our next class.